Hello everyone and welcome back to this fourth session. So now we have so far talked about the theory about the background of microservices, what is the Spring framework all about and all that. So now let's get our hands dirty and create a simple microservice. So before we proceed to create the microservice, the following are the essentials which are required in order to create a simple microservice. So first you should have your Eclipse IDE downloaded and installed in your local computer. It should have JDK 11. So for this course, we are going to go with Java version 11. So I highly recommend that you have version 11 so that you are able to follow along in this course and you don't have much of errors. So next you should have stable internet connection, because when you are downloading Eclipse packages, if you have a very slow internet, then it will take a longer time. Next you should have something called as a Postman. So the use of Postman is like whenever you develop a API server, and in order to query your API server, you can use API in order this Postman API testing application in order to make a call to your server and get the response. And finally, we will use a service called as Spring Initializer, so which is accessible over this website start.spring.io. So what this is useful is whenever we want to create starter project, like having some basic code of Spring Boot with the functions we want, we can just do that out of the box. So we'll be seeing all of this once we'll be getting started with creating a microservice. So now let's head over and create our microservice. So before we go ahead and create a microservice, so as I said, the first step is you have to install your Eclipse IDE, and when you install the Eclipse IDE, along with that, even the JDK or the Java development kit also gets installed. So to install Eclipse, it's very easy, as you may know, that just Google for Eclipse download. The first link that you get, Eclipse downloads, or in the site eclipse.org/download, click on this. And on the left hand side you will see something called as Get Eclipse IDE 2022-6. So at the time of this recording, this is the latest Eclipse IDE that we have, but in case you're seeing this as a later point of time, then this version might get updated. So however, that doesn't really matter, so you can even download the latest IDE as well. So just click on this download button based on the operating system you're using. So for this course we are using Windows operating system, so the steps that you see here will be for Windows, but even the same applies for Mac and Linux as well. So just click on this and the Eclipse will get downloaded after some time. So just to save some time, I have already downloaded the Eclipse IDE, and I'll just show you the steps that you need to do after that. So once the installer is downloaded, open that installer. You'll see a windows like this where it will ask you what is the Eclipse IDE that you want to install. So click on this option where it says Eclipse IDE for Enterprise Java and Web Developers. Okay, so this is the one which you have to select. And once you select that, you'll get this window where it will ask you to to select the Java VM which you want and the installation folder. So this installation folder can be any location in your local computer, that is up to you. And for this Java, what you need to do is just click on this drop down and select this Java version 11. Okay, not version 18 or 17, but version 11. So as I said, we'll be proceeding with version 11 in this course. So it's recommended that all of you select version 11. So all of us have the same code and consistency. So once you have this, you can just click on install. So based on your internet speed and the server speed of Eclipse, this might take anywhere between 5 to 10 minutes for installation. And once it's installed, you will get a button to launch. You can just launch your Eclipse. And once it is launched, you'll get a window like this. So this is the high level summary on how to install the Eclipse. For Postman, all you need to do is just go to a browser, type Postman, download. So the first link that you see in the Google, which is postman.com/download. So just click on that. So here, based on the operating system, you will get the version. Just click on that. And once the installer is ready, so once the installer is completed and just open it, it will automatically install the Postman for you. And you'll see the screen in your computer, which says create an account, a free Postman account lets you, and all this. So you don't need to really create account and all. So for the starters, all you can do is just click on this link below, which says skip and go to app. So just click on that and it will open this Postman UI for you. So that's it. You have also installed Postman. So the three major stuff, which is Eclipse, the JRE or the JDK 11 and the Postman, the three of these stuffs are ready for us to use. The fourth thing that we also saw is the Spring Initializer. So I'll just show you what is the Spring Initializer all about. So just go to this website start.spring.io. So what the Spring team has done for us is, so as I said, there are a ton of Spring projects which can be used for a variety of purposes. So instead of you writing all the code by yourself and linking all the dependencies by yourself, all you can do is just generate a starter project of that particular project which we want and just write the business logic on top of it. Okay. So for now, what we'll do is, since we are going to use a Java project and a Maven project, so this is all default selected, right? So Maven, basically you can have a Maven project or a Gradle project. So Gradle is basically a newer type of versioning or a newer type of build tool, which gives you some additional functionalities as well. But we will use Maven, which is kind of used now in the industry. And for the language, we'll go with Java. And the Spring Boot, the current version is 2.7.1, which is auto selected. And here we have to give a few project metadata. So the first is group. So if you are already aware of the Java naming conventions, you know that this really follows the opposite of whatever is your website name. So in case my website name is say skilllink.in. So here my group name would be something like this. So in our case, what you'll do is we'll just give the name of a project as demo. So I'll just give it as com.demo, and the artifact and the name will also be demo, and description can be like demo for Spring Boot. This is fine. Packaging will be jar. That is also fine. And Java, since we are going to use 11, just click 11 over here. Okay. The next, it will ask us to kind of install the dependencies. So dependencies are nothing but the various Spring projects that we saw, right? So here you can select all that dependencies and other stuff which is required for us in order to create our project. So the first dependency that we'll require in order to write our application is Spring Web. So either you can see from here or you can also search over here. So you can just type web, and the one which shows Spring Web, you can just click on that. Okay. And there are also a ton of other dependencies which you can see over here. So for the time being, we'll just go with Spring Web. Okay. And that's it. So you can just click on generate right now. So what it will do is it will kind of download a zip folder for you. So next, just go to the downloads folder. So, and you just extract this code. Yeah, so I've extracted this code over here. You can see this demo now. So that's it. We have our basic Spring folder ready now, right? So as I said, Spring gives you a lot of starter project, which helps you to kind of fast track your application, right? So this is the practical demo of that. You saw now that, just by selecting a few options, we were able to create a quick starter project, right? So even for a complex application, this is how you start it. So based on whatever dependencies you have, you just kind of select those dependencies and the language you want, and you can get the starter project created. So the next step is now open Eclipse. So once you open the Eclipse over here, just head over to the file over here, and in the file you will have something called import. Click on that, and in the import there will be something called as a Maven. Click on Maven, and here there will be something called as existing Maven project. Click on that, give next, and here in the root directory just hit on browse. And now just go to the starter project which you downloaded. So in our case, it was demo. So under downloads, I just went to demo and I selected this particular folder now. So once I do that, automatically you see that, this pom.xml will come over here. So pom.xml is nothing but it's kind of a file which gives all the dependencies and information about the project. So once you see this, just click on finish. So at the bottom right hand side, you will see that, there's this small progress bar which is running, which says importing Maven project 9%, 10%. So depending on your computer speed and internet speed, this will take some time. So I just request you all to hold on till this is completed. And meanwhile, till it comes, what you can do is just go to Windows over here, go to Show View, and you can click on Project Explorer. Yep. And once you click on that, just click on this button over here and this will expand. So this will now show you the project which has been opened. So till this Maven importing is completed, we won't be able to run our application. But what I'll do is till then, I'll just try to quickly explain you the structure of what is the structure of the Spring project all about and what we were doing over here, right? So the first folder that you see over here is under demo. You have something called the SRC, and inside this SRC you have something called main, and inside this you have Java and resources, right? So this main Java, this Java is where this is have all the Java core packages and classes which we'll be writing for our application, and anything which is non-Java in nature, such as any property files or Spring configuration files, all those kind of files will be going into this resources. And here we don't have another folder here, but usually there'll be also another folder called web app. In case you are also having any deployment descriptions and all, you can put it in that web app. And you'll see this test folder over here. So this is nothing but writing all the unit test cases. So that is why we have this test folder. So again, here you just have Java folders, which means that you'll write test cases for Java application over here. If you also want to write some test cases for non-Java resources, such as property files, configuration and all, you can have a folder over here called resources, just like above. And in that you can dump all your test configuration. And apart from that, pretty much same. So target is nothing but here you all have the metadata, and these are just the pom.xml. As I said, this is the property file of your application, and that's it. These two are the Maven commands. So you can see here that the progress is going good, and the download is going on. So meanwhile, I'll also tell you quickly about another quick thing about Spring. So for that, I'll just go to the whiteboard. So whenever we develop any Spring Boot application, right? So we kind of split our application into layers, okay? So the first layer, this is also similar to what we discussed about the parts of application. So first layer is something called as the presentation layer, which will be talking to the business layer, which will be talking to the persistence layer, and this will be talking to the database layer. So what is all this about is presentation layer is nothing but as I said, this is the front end part of your application that your user interacts with. This will make the calls to the backend and fetch the data and show it to the user. Business layer is nothing but this is the core business logic part or the services part, which is responsible for implementing all the business logic and validation. So anything that deals with any validation, authorization and all that stuff, so that will be handled over here. Persistence layer is nothing but this is the part where all the logic for talking with your data and storing the data in your database and all that will be handled over here. So anything where you want to convert your data or do all that stuff, that will be handled in the persistence layer. And finally, the database layer is where the actual physical database MySQL, MongoDB or H2, those kind of database would be kind of residing over here. So this is kind of the Spring Boot architecture. So if we have to translate this in terms of Spring objects, so basically what it is if you just kind of think about it, so this presentation layer is nothing but kind of the client which will be making the request, that will be kind of handling flowing over to the controller, which is nothing but the business layer over here. Then it will be going to the persistence layer, which is nothing but the service layer, and from there it will be updating the database. So this is how the flow goes of the Spring Boot. So this is just kind of a quick detour we did just to make you guys understand how we kind of structure our Spring Boot code. So now let's go back to the Eclipse. We see that the import is completed because down we don't see any progress. And also here if you see that, you'll see that there is a new folder created which is called Maven dependencies, and if you just open it, you'll see that now there's a ton of dependencies which has been downloaded and installed. So that is the beauty of Spring, right? So just by configuring and selecting a few of the dependencies, it is internally able to find out what are the other dependencies it has, and it is able to download and attach all those Maven dependencies by itself. Right. So as I said, the core of the application code is sitting in this SRC main Java. So I'll just go to this SRC main Java. You'll see that a package is already created called com.demo.demo. So this was the name that we gave, right? So com.demo was an artifact name, and this, if you just come to the Spring, so if you just come to the Spring website, you see that the group name was com.demo and the artifact name was demo. So that is why our package name is com.demo.demo. So coming back, so if you just open this package com.demo, you'll see that there is a Java file created which is called as demo application. Just double click on that, and you will see that there is already some dummy code written which just says public static void main, meaning that this is the main class. And here you will see something called as a Spring Boot application with a @. So anything in Spring Boot application, in Spring Boot code which you see with @ symbol, which is nothing but it is called as the Spring Boot notation. annotation. So what is Spring Boot annotation is, so like it is basically a metadata which tells your application that, what is the properties or what it is, what are the information that are associated with this particular code. So in this case, what we are telling our code is this particular application, for this particular application, this file is the main file for the Spring Boot application. Okay, so that is the use of this Spring Boot application annotation. So don't worry, we also have other annotations as well. So as and when we'll be using each of these annotation, I will just quickly tell you what those annotation does. So for now, you can just remember that whenever you create any Spring Boot application, so the main class of that particular application will have this @Spring Boot application annotation, and it will, when you use that, it will import in order to use that, you have to import it from this particular path. Okay. So now, in order to create our test microservice or test application in Spring Boot, what we will do is we will just go to this package over here, right? And so if you already used like created Java, but in case not, let's just go through that procedure of understanding how do we create a simple application, a simple class in Java, right? So all you need to do is just go to this package over here, right click on top of this package. It will open this context menu. Just click on this new over here, and here you just select class. So that will open this window for you. So what we are doing over here is now we are creating a separate class which will be doing which will be handling a request for us. So as you know, microservice is nothing but just a API. So what is a API? It basically is a service which kind of accepts a request and returns a response, right? So in our case, what we'll give the name of this class is, so since the name of our application is demo, so we'll follow the same name nomenclature. So first we will write demo, then, and since this is going to be a REST controller, okay, so we will write the name of this class as REST controller. So just remember that, this has to be a Pascal casing, so which means that the first letter of each word has to be in caps, and you don't need to do any of the other changes. So just give the name as demo REST controller and just click on finish. So once you do that, so automatically a new file gets created under package with the name demo REST controller. And here you see that, by default, it has just created this template code and left it over there. So now what we need to do is we have just created a new class where we are now planning to write our microservice. Okay. So now what we will do is, since this is just a very simple microservice, we will just first write a microservice which on hitting which we just get hello world. Okay. So how to do that? So the first step for that is just above this public class demo REST controller, just click on that, the line above that, and press enter. And after that, just type @. And since this is going to act as a REST controller, we have to use a Spring notation called as REST controller. Okay. So just type REST controller. Just ensure that, the R and C are capital over here. So once you finish typing REST controller, you will see a red line below that because we have not yet imported that package. So to resolve that, on the left hand side, just click on this icon over here. So it will say that, once you click on that, it will say import REST controller from org Spring Framework this. So just click on that and automatically now that gets imported for you. So this is another beauty of that. You don't really need to remember each and every path and package. So just type that name. Once that error comes, click on that and then you can import. So this is the step one, where first you convert this particular class as a REST controller, okay, using this the Spring Boot annotation. The next step is we have to now define the API. And before we proceed further, in case if you guys are not aware or you guys are not clear, let's just quickly get into whiteboard once. So how does a API or a REST works? I'll just give you a very simple definition of that. So just assume that this is my application or my server. Okay, so just assume that this is my server and say maybe the name of my server is say skill.com, just for example. Okay. And I have a ton of services which has to be exposed to the outside world. So what I will do is under this domain of skill.com, I will have a ton of services exposed to the outer world. Okay. So maybe I would have something like skill.com, /HR, skill.com / maybe marketing, skill.com / something. So each of these services would be identified with a particular URI, which is nothing but uniform resource identifier. This is different from a URL. So what is a URL is basically nothing but when I say skill.com, that is a URL because it tells a location. But in this case, in that server, it points me to a particular identifier of that particular resource. That's why it is called as URI. Okay. So in case of APIs, we use this word as URI, endpoint URI, to specify the address. So this is how generally we kind of expose the services. But inside the server, what happens is each of this port will be running in a particular, each of the services will be running in a particular port. As I said, microservices are independent and deployed independently. So what happens is this HR microservice could be running in 8080 port, this skill would be running in 8081 port, this would be running in 82 port, this will be 83 port, and so on. So what happens is inside the server, we reserve one port for one particular service, and internally what happens is if you want to kind of access your service, what you will do is you will do skill.com:8080, then you do /skill or HR or whatever you want, right? So this is how we normally access the service internally. But when you are exposing it to the outer world, you just give it like skill.com/HR, and your API gateway will then internally convert this address to this address and route it. So that's why remember when we talked about microservice architecture, we also talked about API gateway. So what API, one of the work of API gateway is also this. So from outside world, we don't give the end user all this port number and all. So what we just give them is skill.com/something, the microservice name. Internally, this API gateway will have the mapping that, okay, if it is HR, then it has to go to the 8080 port of this particular server and then point it to the HR service. So that is the work of gateway. Okay. So now with that clear, let's get back to Eclipse. So now as you saw that since we are going to expose a variety of services with each having its own name. So let's now first kind of like, write a simple service which will just return maybe the word hello world. Okay. So how to do that? So the first step of that is you have to use an annotation called as get mapping. So remember that as I said, in order to write any Spring annotations, all you need to do is just use @ and then start like just type the name of that particular annotation in Pascal casing. So once you do that, you'll get this kind of this red annotation, this red error over here, meaning that, you haven't kind of imported that particular package. And before you just click on this, this get mapping has to be completed, like the syntax has to be completed. So what we need to do is just open close bracket. And inside this, all you need to type is value equal mark, double quotes, and inside this just give /. Okay. And here just close the bracket. And now you can, so before that, all you need to do is just like, write get mapping, open close bracket, value equals to double quotes /, and still you'll get this error. But before we kind of auto import, we have to finish this syntax. So just to let you know what this get mapping does is, so basically what we are doing over here is whatever function we write below this, right? We are just mapping the HTTP get request of that particular request. So in this case, / means if the user hits, like if the end user just hits our server, which is in our case localhost:8080. So then that particular request will get mapped to this function what we are writing right now. Okay, and it will fetch that request and it will handle it to this particular function. Okay, that is the work of get mapping. So once you give this annotation, after that you have to bind a particular method below this. So what we'll do is we'll write public, and since we are just going to return a simple string, the type is going to be a string. Next we have to give a name to this method. We'll just give it as say hello, then open close parenthesis, and here we just return a simple hello world. Close it with a semicolon, and let's make it better. We can rather say hello skill link. Okay. And now you can complete this import. So all you need to do is just click on this round over here. You'll get this import get mapping. Click on that. And now this error will be gone, and also this works. So now let's summarize what we have done so far. So the first step was we created this Java class file outside in this package. So that was step number 1. How we did it, just right click on this, go to new, click on class, and here just give the name of the controller which you are creating. Since we are creating REST controller, we just gave the name of the application and REST controller name. Also remember that the nomenclature or the naming of the file should be such that even if a new developer comes, he or she should be able to make out what this file is doing. So that's why we are giving it the logical name of REST controller, meaning we are writing a controller which is going to handle the REST calls, right? So then after that, what we did is we just added this annotation of REST controller on top of this main class, meaning that telling that, this entire class is going to act as a REST controller handling all the APIs. And next, for each of the API endpoint which we are creating, now we are going to create a particular method to handle that particular request. And in order to make this particular API handle this particular function handle this particular API, we have used this get mapping annotation. So what this get mapping will do is it will listen to the server request, and any request which comes on slash, it will take that and give it to this particular string method. This particular hello method. So in this case, what we have done is whenever any request hits on just localhost :8080, we would be just returning them the string of hello skill link. Okay. So now let's test whether this works fine or not. So how to test it? So if you are a particular traditional Java server developer, or you know a bit about API development, you know that, before you even run your server, you have to configure your server and do all that. But since, as I said, the Spring Boot comes with its own set of internal server configured, we don't need to do any of those configuration. So all you need to do in order to run your application is just go to this package over here, right click and click on run as Java application. That's it. So, and now now for the first time it is asking select the resource to save. So what happens is, before you run your code, it's always better that you save your file. So in this case, you can always just click on this checkbox. Okay. And now that's it. So what happens is it will open a new console tab over here where it will say Spring, the version, and you'll see all this 4-5 line coming. Sometimes you will see this pop-up coming on Windows, which says that, Windows Firewall has blocked some of these features. So if that is the case, just select that and give allow access. So that will ensure that, Spring Boot is working fine. So now your server is up and running. So how to test whether your server is up and running? If you see the last line, right, in this console, it will say that started application in 6.16 seconds, right? And JVM is running. So which means that your application is up now. So in order to test, we can test it in 2 ways. So the first step is you can go to Chrome. Just go to Chrome and type localhost :8080. So this is the default port where your application runs, and press enter. So you will see that, it has given us the value of hello skill link. So this is one way of testing it. So this way of testing works if it is just a simple payload, or you're not sending any payload, like it is just a simple get request. The other way of testing it is you can also do it in Postman. So how to do it in Postman is, so just go to your Postman over here. So since this is the first time we are kind of testing our application, what we can do is we can just first create a collection. So collection is nothing but, you can just basically call it as a project or a microservice. So just for our case, we are just giving it the name of demo, and inside that now we can add the lot of other microservices or functionalities which are developed inside it. So here, if you come now, you'll see something called as add a request under demo. So just click on that. So you can give a name to this request. So in my case, I'll just give it as slash. Okay. So this is going to be a get call. So I'm just giving a name as get, and here the URL is going to be localhost :8080. Right. And now to test it, all I need to do is just hit on send. You'll see that here now the response has come as hello skill link. Right. So that's it. So this is how you can test your application in Postman as well. So in the due course of time, we'll be using Postman extensively especially when we are doing kind of post call and other calls. So Postman is generally preferred for testing the APIs. So I hope till now it is clear how we have written a simple application and how we have kind of tested it as well. So I'll also now give you a few other scenarios, and always remember that whenever you're making any changes to the application, always stop your server and start it, or else the data won't get reflected. So how to stop your server is in the console on the right hand side, you'll see it like a stop button in red. So just click on that. It will stop your server. So now your server is down, and to validate that, all you need to do is just go and refresh this. You'll see that, this will spin for some time and later throw error. So that means that, your server is now stopped. So always ensure that, whenever you want to test your latest code, stop your server and restart it. That is one of the important point. So now let's see another scenario. So let's now create, I'll give you a scenario, right? So now let's just create an API which is just going to return an object. Okay, so object is nothing but like a key value pair. So how we can do that? So the first step is we have to write get mapping. So I can do it in the same file as well, right? So in this same demo res controller, below this hello, I can just now create another method. So I will just type get mapping value equals to double quotes. Here I have to specify the name of my microservice name, right? So here I'll just give it as maybe JSON. Okay, so which means that when my user is hitting /JSON, this particular method will get invoked. So next is public. So here, since I'm going to kind of return a JSON object, so I'm going to set the type of this particular method as map, and inside map, I'm going to just return a string and object. And again, you'll see there's an error. So for that, what you need to do is first we'll complete this line and then we'll resolve the error. So then the name of this object, I'll just give it as map, and I will then initialize a new hash map. So now what we can do is we just need to import all this stuff. So first I'll import map. So just for that, you just need to click on this error, click on this import map. And here we just missed out parentheses. So that is done. So the next is we also need to import the hash map. So just click on this error over here, hit on hash map. So this error will get resolved now once we just complete this kind of thing. So now what we'll do is inside our map, we'll just put a couple of keys. Okay. So what I'll do is maybe I'll just say key one, I'll just put name, and the value of that I'll just put as skill link. And the second key, I can just put it as maybe location, and I will put the value as Chennai, for example. And finally, I'll return this map. So there has been a small syntax error over here. So that's why we're getting a ton of error. So basically here, we forgot to initialize the object, the method name. So here in our case, we'll just give it as get. And now it should be working fine. Align it a bit. So here now for map, we would say give the type as map string object, and that's it. And once you finish that, yeah, now we are good to go. So I'll just summarize what we have done. So here we are returning an API, like we are returning just a string for an API when you hit the slash. But in case you want to return the object, right? So if you take any real world scenarios, we normally return objects, JSON objects. We rarely use API which just returns us string. So in those kind of scenarios, what we can do is we have just created a simple REST controller which just kind of gives you an object which having two values, one which will give you name as skill link and location as Chennai. So now let's check whether this works or not. So for that, again the same process. So as we have already stopped our server, just go back to this demo, click on this run Java application, and that's it. So now your Spring application will again restart, and once you just see that started application and 5 seconds, whatever the number over here, so you can head back to maybe Postman, and over here we'll just create another request. Okay, so how to create another request is just come over here in the demo under collection and just click on add request. So here you just give the name as maybe /JSON. The request here will be localhost 8080/JSON, because that is the name of the controller, the service which we have given. Now you hit on send. So now you see that, in the response we have got a proper object, so which has the name as skill link and location as Chennai. So this is how normally we kind of interface between services. We kind of send between JSON objects and not strings or numbers and any those kind of things. Okay. So now we are clear that how we can create simple services using various types and all. So using other JavaScript notations, Java notations, you can kind of create different types of API responses that you want. So in your assignment for this week also, the assignment would be using the same concepts which I learned right now. You would have to return the current server date and time as a string whenever the user makes a request. So say for example, if the user is making a request right now and the time is say 16:54:25 of today, whatever day is, so you have to return it in that particular format. Okay. So the details would be of the assignment will be shared to you later, but this is what you have to do. Create another service which would be kind of exposing that functionality for you. And you can use all the built-in Java libraries and classes which helps you to kind of get the current date, time and all that stuff. So coming back to the discussion. So far we have seen that how to create different APIs and return the various values based on what you require. Since this is just a demo application, we have just hard-coded values and sent it. over the course of time, we'll actually also connect with a database and also make some transformation on the data before returning it to the end user. So that was all about this creating this sample API REST controller. And before we wrap up, I also wanted to show another thing to you guys. So at present, we are running the server on the default port, which is 8080, as you can see in the log also over here. But what if we want to run our server on a different port? So before doing that, I will just stop our server by terminating it from this console window over here. And after that, what we can do is just come to your Eclipse, just click on anywhere in the code and just press Ctrl Shift and R together. It will open this window. The combination is Ctrl plus Shift plus the letter R. So when you press on that, you will get this window with the name Open Resource. So here you just type application. You will see a file over here called application.properties, which is sitting inside your SRC main resources. So as I said earlier, resources is nothing but anything which is non-Java related configuration and other files, which will be sitting over here. So either you can manually just navigate over here and open it, or directly we can also search for a file from this finder and open it. I highly recommend that you guys use this often because it saves you a lot of time. So just click on this application properties. So you'll see that this is a blank file as of now. So this file is where you configure most of the application related properties. So now I'll just give you a simple demo. So in case you want to change the port of this for application now, say from 8080 to something else. So we can do it by here. So all you need to type is server.port equals to, and now you can type the value you want. So say for example, I want our port to run on say 4200. So that's all I need to do. Save this file, and now when you just run this application again, so just go on the package and just click on run as Java application, the same procedure. So now you will see that the server will be running on a different port, which is 4200. You can see over here, and the application started. So if you come back to Chrome or Postman and you try running the same request which was earlier, you'll see that now it will be throwing you error that could not send a request. But whereas if I now just change this port to 4200 and again run it, you'll see that this request is running, and same for the other one as well. So if I just run it on 4200, you will see that hello scale link is also coming. So this was also just a short demo to show you how we can manage our application properties with this application.properties file. Over the course of time, there are also a ton of other configuration which will be adding over here in terms of logs and other stuff. So yeah, this was also another stuff which I wanted to show you guys. So with that, we have come to the end of this day one session. And as I said earlier, the assignment for you guys would be to create a new REST API similar to what we have created in the class that will be returning the current server date and time in the format which is given in the questionnaire, and you can just return it as a simple string. And now just let's come back to the slide. So just quickly summarize what we have learned in this week. So in this week, we have learned about the various application architectures, about the various advantages and challenges of application architectures. Then we saw how microservices helps us to build scalable and reliable applications. Then we also saw how Spring Framework helps us to implement microservices faster and efficiently. And finally, we created our first microservices using Spring Boot and Eclipse IDE. So with that, we'll be wrapping up the session for now. Thank you and have a good day.